This video is designed to help you to work through the questions in exercise 4D. So the gradient of a straight line is just a number, and that number describes two things basically: how steep a straight line is and what direction that line goes in. Now you would have been introduced to this in year 8. The letter that we use in maths to describe a gradient or a slope of a straight line is the letter M. And you may have seen last year that the gradient is equal to the rise over the run. And the 4 different types of gradients you'll see in year 9 are positive gradients, negative gradients, zero gradients, and undefined gradients. So when we're looking at a straight line, if we're looking at it in terms of moving from left to right, we're looking what direction is that line going. So the first one, the positive gradient, if you're looking at that graph from left to right, the graph is going upwards. From left to right, the negative gradient is going downwards. From left to right, the zero gradient is flat. And from left to right, that undefined gradient is vertical. So a couple of little tricks to help you. If you're not quite sure by looking whether a slope is positive or negative, these two little hints might help a little bit. So if you're imagining a cyclist having to ride up and down a slope, if that cyclist has to push to get up there, P for push, P for positive, that might help you to remember positive gradient. The cyclist has to push to get up there. With the negative slope, you might want to look at it as though you can draw a capital N on it, like this. So if you can draw an N on there, a capital N, and the graph runs along that N negative, that might help you to remember a negative gradient. So they're just two little tricks that may or may not be useful for you. The sort of questions you're going to be asked are things like these ones. So state whether the gradient is positive or negative or zero or undefined. And then if you can find the gradient, what is it? So hopefully by looking, the first example, you'd imagine if you were cycling and you hit that hill, you would have to definitely push to get up that hill. So this one is positive. Again, if you were looking at that second example, you can draw a capital N on there. N for negative, so straight away this one's negative. Occasionally you'll see one that is flat or one that is vertical, and those two are either zero or undefined. To actually find the gradients in there, what we need to look for, once we know what direction they go, are they positive, are they negative, that's step number 1. The next step is to actually work out what is the number that represents how steep that line is. So in this particular case, the first one, we know a point at 0, 0, I can see pretty clearly, and I know a point at 2, 4, which I can also see pretty clearly. So what I've got to work out, if I'm trying to get a gradient and I want rise and run, those two numbers, to get from where I am up to where I want to go, I would need to travel up 4, so rise 4, and then I'd have to travel across 2, run 2. So 4 divided by 2, 2, I know that gradient's positive, so in this first example, gradient is 2. In the next example, if I again choose 2 points on that line, so I can see a point right there at 0, 3, and I can see a point there very clearly at 4, 0. And again, in terms of how do I get from one point to the other, I know this gradient is going to be negative. So in this case, I can straight away say I know that is negative. To get from one point to the other, either from here up or from here down, doesn't matter, you'll see I have to travel the same amount of distance. So 3, and my run 4. I know that gradient is negative, so that particular gradient is negative 3/4. So if you need some more information on that concept, there's 2 good videos in your textbook to have a look at. Example 7 and example 8 run through this sort of stuff in more detail, so you might want to watch those as well. If you were just given a question like this one that says find the gradient of the line joining those 2 points, one possible way to start is to draw yourself a little sketch and see what that looks like. Where are those 2 points, and then can I calculate the distance between them in terms of rise and run. So the first point, -3, 4, would look something like this. And the second point, -3, 2, sorry, would look something like this. So the line that joins those 2 points would look something like this. And what I need to then be able to do is to calculate the gradient. So when I'm doing examples like this, I always look at direction and then how steep is it. So direction, straight away I know I could draw an capital N on that graph if I wanted to. So I know the gradient is negative in this case. So I would always start like that. Now I've got to figure out how much distance is covered in terms of rise and run to get from one point to the other. So if I was looking, for example, how far do I have to go to get down here, and then how far do I have to go across to get over there, I need to be able to calculate the distances. So in terms of the y, the distance I've travelled on the y values, if I'm up here at 4, I need to move 4 to get down to 0, and then I need to move another 2 to get down to here. So I'm overall moving down 6 units on that graph. And then in terms of horizontal distance, if I'm in line here with -3 on my x-axis, I need to move across 3 to get to 0, and then I need to move across another 3 to get over to where the point is. So I've travelled effectively 6 in the horizontal direction. So to simplify my gradient there, -1. If I wanted to do that without drawing a diagram, there is another formula or another rule that I can use. And what that rule is really saying is the difference in the y values divided by the difference in the x values. x1 and y1 are just the coordinates of the first point, point 1. So the x coordinate of point 1 and the x coordinate of point 2, for example. And then x2 and y2 are just the x coordinate of point 2 and the y coordinate of point 2. So you just decide which one is point 1 and which one is point 2. Usually the first one that's written down makes sense to make that point 1. So this is the x coordinate of point 1. And this is the y coordinate of point 1. And then if the next point is point 2, this is the x coordinate of point 2, and this is the y coordinate of point 2. So using that formula, if I want to do this without actually drawing any diagram of it at all, I can just substitute in my values for x2 and y2 and x1 and y1 into my formula. So my y2 value is -2. Take away my y1 value, which is 4, divided by my x2 value, which is 3. Take away my x1 value, which is -3. And if I was to simplify that, -2 take away 4 is -6. 3 take away -3, so add 3. 3 plus 3 is 6. And the gradient is -1, which I knew from actually drawing that diagram on the previous slide. Another type of question I could get, it's a little bit harder again, is if I know the gradient and I know one of the points and I sort of know half of the other point. So if the gradient of the line joining the 2 points 3, 2 and 4a, so I don't know what that number is 2, find a. So knowing my formula for finding gradient could help me to solve this equation. So if I substitute in values for y2, y1, x2, x1, and m, so in my question you can see I know x1, if this is 0.1, and y1, and I know x2, if this is 0.2, and this is y2, and this 2 is m, the gradient is 2. So I have values for every single thing I need in that formula. So if I substitute values in, then I can solve to find A. So if I was doing gradient is 2 is equal to y2 is A, y1 is 2, x2 is negative 4, and x1 is 3. So I've got myself an equation that now I could solve. If you had your calculator, and this was a calculator active task, it'd be very straightforward to just do a solve this equation for A. Okay, so you could easily do that on the calculator if you had to. This one I'm going to pretend is not a calculator active task, so we have to do this by hand. So now it's just a matter of simplifying and solving that equation. So if I simplify that denominator, 2 is equal to A minus 2 over negative 4, take away 3, negative 7. Now it's just a straightforward solve the equation. Get rid of the negative 7 by multiplying both sides by negative 7. And I end up with negative 14 is equal to A minus 2. Get rid of the 2 now by adding 2 to both sides, and A would be equal to negative 12. So fairly straightforward algebra once you understand how to substitute those values into the formula. And sometimes you'll get questions like this one that ask you to find a gradient and then describe what it means in the context of the story. So something like this one, a horse galloping for 20 minutes and covering a distance of 15 kilometres. We can see the distance and time graph. So it's pretty obvious, hopefully, to you that the gradient of this line is positive. If we're talking about rise and run, rise is 15, run is 20, and you could simplify that fraction. 5 goes into both of those numbers, 3 times and 4 times, so the gradient is 3/4. When it says describe its meaning in the context of the story, really what that's sort of saying is, what does this describe in relation to what's happening in the story? Basically, that is a rate of change. How is the distance changing in relation to the time? And what it really means is a speed. It means that horse is running at a speed of 3/4 of a kilometre per minute. So hopefully that helps you to answer some of the questions in exercise 4D.